everyone, my name is Rajesh Patnaik. So today we are going to discuss the concept of fog computing. So what is a fog computing? In the previous class, we detailedly discussed the concept of cloud computing. We know that cloud is the storage. It is a set of or cluster of servers which is capable of storing different types of services. We already know that. So there are mainly three types of services we already discussed regarding SaaS, software as a service, infrastructure as a service, as well as we already understand the concept of platform as a service in cloud computing. But what is a fog computing and what is the use of the main purpose of the fog computing? Nowadays, IoT devices are using. So if you take the example of smart cities or smart areas, so smart homes, every particular area, we are having the lots and lots of IoT devices are there. Every IoT devices are embedded with the sensors. These sensors are storing so much of data, so that particular data which is storing in the cloud, so this vast data, whenever so it is going to store lots and lots of data. Let us go for example, I have a cloud. In that particular cloud, I want to store the data. For example, the camera, take a web camera. Nowadays so many people or organizations are using the web camera. This web camera is going to be generates huge amount of data. That means it is always capturing the data. So in this particular data, so always capturing this particular data that is stored in the cloud, so it is going to be take lots and lots of time to store the data. So nowadays there is a concept of fog computing. The fog computing is a mediator, the end user and cloud computing. So cloud means a set of servers or cluster of servers. In between we have a fog computing, because of we have lots and lots of IoT data will be there. Sorry, that means IoT sensor data which will be stored, that may be used, processed and stored and organized in a cloud actually. But always it is not useful. So after the it is after it is unwanted data, you must remove the data. Otherwise there is huge amount of data is going to be stored, so that leads to the bandwidth of the network, as well as so many latency, data latency problems, and so many problems will be there. So for that particular purpose we are used the fog computing as a layer. So for processing of IoT data, okay, let us go and understand what is a fog computing. So fog computing or fogging is the term that is coined by the Cisco. Cisco was first. It was introduced the concept of fog computing. It is also known as fogging. The idea of fogging, fog computing, is extended the cloud nearer to the IoT devices. That means I already tell that is to extend the cloud. So because nowadays lots and lots of IoT devices, it is continuously generating the data. So it is used to transfer from one place to another place. That means end user to cloud. So cloud, we know that the cloud provides different types of services, like it may stores the networks, it is giving a platform, it giving as a software, so many things we already understand it. But IoT devices is going to be generated huge amount of data. That particular data will not be stored in cloud computing for the processing and um, for mainly for the processing and storing purpose in the cloud. So we are using a fog computing as a middle level layer to store the data. The primary aim to solve the problem faced by the cloud computing during the IoT data processing. I already tell that. So if the data the generated by the IoT devices which is stored in the cloud, so in the cloud only it is going to be processed and It is also stored in the cloud. So lots and lots of data, like if you take a camera or any sensor that is continuously storing and processing the data, it is very difficult to get. So nowadays all are using the fog computing. This fog computing is the intermediate. So it is going to be process in the place of fog computing only. For example, any IoT data process is there, that will be only done with the fog computing, not in the cloud computing. If automatically the data is processed, then only if it is, if the organization or the people want to store the data in the cloud or want to use that particular service, then only it will be stored in the cloud. So in the next point, an intermediate layer between the cloud and devices, we already understand it, that is fog computing. 40% of the whole world data will be come from sensors alone by 2020, and 90% of the world's data were generated only during the period of last 2 years. So that's why the main concept that was introduced, the concept of fog computing. 2.5 quintillion bytes of data is generated per day, and total expenditure on IoT devices will be dollars 1.7 trillions by 2020. The total number of connected vehicles worldwide will be 250 millions by 2020. There will be more than 30 billion IoT devices nowadays it coming. The amount of data generated by IoT devices is simply huge. So that's why the fog computing was introduced. If you understand, 40% of the whole world's data up to sense, because the data coming from the census, and the generated period lost 90% of the, and 90% of the data that is coming from the IoT devices. So that's why. So it is going to be making the lots and lots of cost, because if you maintain the cloud, you need to go for the servers. Servers having a lots and lots of cost, and so that's why we are moving like this. And next, we are going to understand some more things regarding fog computing. So we already understand it. So if the IoT devices is there, or the people who uses the IoT devices, and they want to interact with the cloud, so cloud provides the different types of services. It provides the network, it provides the software, it provides the infrastructure, etc. In the cloud. But so the data, lots and lots of data is going to be stored in the cloud. So in between we need to for example, if we are not going to process the data in the cloud, so we want a middle level layer. The layer called is a fog. Okay. And in the next, why fog computing? Why fog computing? There is a issues. The three issues are: lots and lots of volumes of data that is stored in the cloud. That is the one of the major issue. That's why we come for fog computing. As well as lots of data latency, because entire computing and data storing is done in the cloud only. So there is lots of data latency will become, as well as bandwidth problem. So in the real time world, there is lots and lots of IoT devices. These all are connected in a network. So the network bandwidth, if it is connected to a cloud, the network bandwidth will be huge, because it must be transferred. For example, if you want to retrieve a certain data from the cloud, so it must be interacted with the cloud server, then it comes from that particular cloud. Means we are subscribing for a particular request, we are getting that particular response to publish the data. So in a network, so it is going to be take the some time. So bandwidth is also one of the problems, one of the issues in the cloud computing. We need a fog, then the bandwidth will be reduced in the network. So what is that? The ability of the current cloud module is insufficient to handle the requirements of IoT. So if you see here directly, if I want to interact with the cloud, present day cloud model, so it sends the data for analysis and storage. It is coming from different IoT devices, that may be a signal points, or that may be an antenna, that may be a real-time web camera, or mobiles, or connected vehicles. There are so many examples was given here. Present day cloud model, these all devices is using by different organizations and industries. They are using for different purposes. So directly if sends the data for analysis and storage, the cloud is used. It sends back the command and make an action. That means everything is going on the cloud. So that's why we need a middle level layer to solve these particular issues. Okay. And in the next we have the first, data volume. What is the data volume? Let us, by 2020 about 50 million devices will be online, and present million, that means 2020 is already gone, and nowadays 2021, so many so it is already it was in a latest some articles it was written that 50 million devices will be using nowadays, and more than 50 billions also using. So the analysis is continuing, and presently billions of devices produces exabytes of data every day. So that means huge amount of data is storing, because of nowadays there are smart cities, smart devices, these all things are going on. uh, Next thing here is devices density is still increasing every day. Current cloud model is unable to process this amount of data. I already tell so many times. And private firms, factories, airplanes companies produces the colossal amount of data. That means low huge amount of data. So there are different factories, firms, private firms, companies, so much of data is provided. Current cloud model cannot store all these data, and data need to be filtered, because lots of cost is going to be taken. Lots and lots of servers have to be maintained, lots and lots of employees have to be maintained, because cloud provides different types of services to the end user. So in this particular picture at the right side, so private firms is using cloud, factories is using cloud, airplane firms is using cloud for the purpose of storing and processing of the data. So lots and lots of huge amount of data is storing. So the servers will not bear that much amount, because everything is stored, because the data may be useful or may not be useful. It is only for the purpose of the calculation. So not, if unwanted data must be removed, so that's why we will go for the fog computing. So latency, so we are time taken by the data packet for a round trip. So that means we are requesting for data to the cloud, and cloud responding to the end user or a device, it will be take some time, because the data will be come in the form of packets. An important aspect for handling a time sensitive data, um, and if edge devices send time sensitive data to cloud for analysis and wait for the cloud to give a proper action, then it can lead to many unwanted results. That means in this particular point, in second point, we already understand it. An important aspect for handling a time sensitive data. So that means there was a sensitive data you need to handle. So it is also leads to latency. Edge devices sends time sensitive data to cloud for analysis. That means a sensor, weather report sensor or camera is going to be captured always, because of the security purpose. So there are lots of sensitive data will be stored in the cloud. So based on that particular data, so the cloud making proper actions to the devices, or it is going to be make certain results. So sometimes it is also giving the unwanted results also. So that leads whenever the data will be used. While handling time sensitive data, a millisecond can be make a huge difference. So that means a small milliseconds will make a lots of difference, because we are using a fog computing. I already tell that. So if it is going to the cloud and getting back, it is going to be take some 3 million seconds, for example 5 million second for particular request. So if you use the fog computing, it is only take the 2 to 1 million second per hour per data. Sending time sensitive data to cloud for analysis, we already understand sensitive data always going to the cloud and for analysis. And latency, what is the formula for the latency? Latency equals to T, means time from device to cloud, plus time data, T data analysis, time data analysis, plus time from cloud to device, where T is a time. So that means time from device to cloud, time of data analysis means processing of the data, and time from the cloud to device, reverse process. That means all the how to calculate the latency, these all combination of sum of all the times we are getting the latency. Okay, latency will be increased if you use the cloud. If you use fog, so the latency rate will be reduced. Okay, in the next, bandwidth. So bitrate of data during transmission, I already in the network, we if you make the request, it is moving to the topologies, and the topology is consisting of different types of switches, hubs, etc. So for moving to the request is moving to the cloud, and coming back from the cloud to device, it is taking some network communication bandwidth. Bitrate of duration is data duration will be increased, and if all the data generated by IoT devices are sent to cloud for storage and analysis, then the traffic generated by these devices will be simply gang. Okay, so that means it is huge amount of data which was stored, that is generated by the IoT devices, consumes almost all the bandwidths. So that means it is used. For example, if my device is going to be making the request to one hub, and hub is making requested to switch, and switch is making requested to the cloud, so it is going to be take the lots and lots of time. So we need to reduce the time if you use the fogging as a middle level layer. Handling this kind of traffic will be simply a very hard task. Billions of devices consuming bandwidth. If all the devices become online, even IPv6 will not be able to provide facility to all the devices. So this is also one of the point. So all the devices become online, even IPv6 will not be able to provide the facility to all the devices. Data may be confidential, which the firms do not want to share online. Okay, so to reduce latency of data, we already understand an appropriate action to be at the right time we need to take, and prevent the accidents and mission failures, etc. So why we are going for the fog computing. And data security, IoT data must be secured and protected from the intruders. So because of whatever sensitive data that was generated by the IoT devices, that must not be stolen by any particular intruders. So always the data is monitored. If you take the web cameras for the security purpose, it was there for 24/7. So every time the appropriate actions would be taken before the attack causes major harm to the network. And operation reliability, for example, what is the operation reliability here? So we understand it. What is the major purposes? We need to reduce the latency. We need to provide the data security and operational reliability. The data generated from the IoT devices are used to solve the real-time problem. Okay, so that means we are not going to process or calculating some data in the cloud. We are going to use the reliability. we need the reliability of data, exact processing of data. Integrity and availability of data must be guaranteed, and unavailability and tampering of data can be hazardous. Okay. So that means in the cloud concept, we are sending the data for analysis and storage using the different types of IoT devices like connected vehicles, or some firms are using the cloud, and hospitals, agriculture, and so many areas they are using the cloud for different purposes. So same concept. So we need the so why we are going for a fog. So there are different purposes. Mainly you need to understand the bandwidth, the latency, and volume. Please remember the things if you write the concept of fog computing. And processing of data at respective suitable places. So that means data can be divided in three types based on sensitivity and time sensitivity data. So you must remember that. And less time sensitivity data, so that means data which is not time sensitive. Extreme time sensitive data should be analyzed very near to the data source. Data which is not time sensitive will be analyzed in the cloud. What is the meaning of that? That means, so every time the data will not be used because of for example, take the web camera. It is always going to be capture the image. It is going to be generates lots and lots of data. Sometimes every day yesterday's data, or some 1 month or 2 months data will not be there, because it is continuously generated data. It is not used, please remove that. So that means so the sensitivity data or analyzed data that is always stored, which is not time sensitive, why not we are storing in the cloud. And that means for that particular purpose also we are using the fog computing. Monitor data across the large geographical area. The location of connected IoT devices can be spread across a large geographical region. Example, monitoring the railway track of a country, or to stat the device, or expose it to harsh the environmental conditions. So that means whenever we are going to monitor the railway tracking of a particular country, so using different types of devices, we are getting the statistics of that particular railway track of a particular country. So only that particular country will use that particular cloud. If you means in for computing will be used by that particular compute, that particular country, for tracking of the sorry the environmental conditions. Okay. And next we are going to understand the architecture of the fog. So sorry, I will go for back. Architecture and cloud services are extended to IoT devices through fog. So that means we already understand it. Like cloud services, maybe that is a network, or that may be a software, that may be a platform, that may be an infrastructure, or that may be any kind of devices, any kind of services extended to IoT devices through fog. So fog is a layer between the cloud and IoT devices. Many fog nodes can be present. Any number of fog nodes can be present. Sensor data are processed in the fog before it is sent to the cloud. So that means if you want to send that particular data, it was a very important, then only we are going to send the data. After processing will be done in the fog only, it is not done in the cloud. Reduces the latency, save bandwidth, and save the storage of the cloud. Okay. So this is the architecture. So in the examinations, if you want to, you have to draw the content like this. Please go through that. So this is a cloud. So there is a fog layer consisting of two fog services. See here, fog nodes may be a router, switch, hub, etc., any type of nodes. So IoT devices are the end users or end devices which is used to interact with the fog nodes, and fog nodes will provide the fog services. That means data will be processed and data will be sensed, everything will be done here, and then if it was useful, then we are going to send to the cloud using the private servers or public clouds or public anything we are going to take in at the right side. So it is the architecture of the fog computing. Okay, characteristics is storage and computing facility and computing like this. We will see all the things. Let us go for that. Characteristics of the fog node is storage, computing facility, network connectivity. These are the important things. If you want to write, please remember some of the characteristics. Storage, in the storage we need to store the data in the at the fog level, and for the processing of the data. And computing facility means you need to process the data, whatever data sent by the IoT devices. And network connectivity means fog services will decided which type of, like example, routers, embedded services, switches, like this. Any type of network hardware connection will be taken care under the fog only. That means network connectivity. And what is the working of the fog? There three types of data, that was very time sensitive data, less time sensitive data, and data which are not time sensitive. There are three types of data that was worked with fog. Okay, so let us see here. Sends the summary of the historical analysis and storage. These are the four nodes. If you see cloud at the top, and nearest fog node, and devices, and aggregate fog node. See here, devices inject the data for the nearest fog node. How it was worked, I am telling how it was done. Nearest fog node, if time sensitive data, then take immediate action. If was time sensitive or less time sensitive data, it will be go to the aggregate fog node. Less time, if very it was a time sensitive data, then the time taken immediate action on the data. If was it was a less time sensitive data, it will be go to the aggregate fog node. So it was non-sensitive data, directly the device will store to the cloud directly. Since the summary of the historical analysis will be go to the cloud. Otherwise, nearest fog node will sense the historical analysis, the storage will be go to the cloud. So this is the working of the fog computing. So how the fog computing will work. So please go through this. And the nearest fog node injects the data from the devices, most time sensitive data, like data which should be analyzed within the fraction of a second, analyze at the nearest node itself, send the decision or action to the devices, sends the stores the summary to cloud for future analysis. Like this, these all things. So most time sensitive data directly go to the cloud. Less time sensitive data, like data which can be analyzed after the seconds or minutes, are sent to the aggregate nodes for analysis. After analysis, the aggregate nodes send the decision or action to the device to the nearest node. The aggregate node sends the summary to the cloud for storage and future. I already tell less time sensitive data. So that was directly it was an important so directly it was analyzed by the fog itself. Non-time sensitive data which can be wait for hours, days, weeks, so sent directly to the cloud for future analysis. So this is the thing here. uh, so advantages of the fog is security, reduces the unwanted accidents, and better privacy, low operation cost. I already discussed in the previous slides. Please go through this. And the benefits, supports mobility. Also, mobility means we know that the mobility concept in previous lessons we already understand it. In fog also consisting of the collection of fog nodes. So whenever the data is moving, means in the concept of vehicles, it will be moved from one place to another place. So the data packets will come from the other router. So one router will passes the half means continuous data packets to the other router. So the data device is acquired from that particular node. So like this, deployable in remote places, better data handling, business ability. So these all are the advantages of fog computing. And applications of fog computing in real-time health analysis, we are using the fog computing. For example, patients with chronic illness can be monitored in real time. Stroke patients analyze data. I already tell so many times in the classrooms, but I tell that regarding a cloud. So in the case of IoT devices, nowadays they are using the fog computing for storing and processing of data. There are three types of data: non-sensitive and less sensitive. Like this, most sensitive, we already understand. Intelligence power efficient system is the application, and other applications: real-time rail monitoring, pipeline optimization, real-time windmill and turbine analysis. So many times in the classrooms I already tell the previous examples, like train tracking, railway monitoring is the one of the example. One of the application. Fog nodes can be deployed to the railway tracks, and real-time monitoring means the speed of the train when it was coming to the destination. Like this, where is that particular train, this all tracking or monitoring thing will be the one of the fog application. Pipeline optimization, that means gases, oils are transported through pipelines. So how much of oil to be passed from one place to another place, and how much oil to be pumped through pipes, and these all things the industrial use IoT applications also be used. One of the application, real time windmill, that means how what is the speed of wind, what is the condition, weather condition. These all things will be stored under fog. Okay. Okay, thank you.